On this episode of Exploration Outer Space, we look at what decades of robotic missions have discovered on Mars.
Every rover that we send, we're unraveling the mystery of Mars.
And then prepare to launch the latest rover to the Red Planet.
5, 4, engine ignition, 2, 1, and liftoff.
Welcome to Exploration Outer Space. I'm Emily Calandrelli. Even though Mars is considered one of the most explored planetary bodies in our solar system, we have just scratched the surface of some basic questions about its formation and its ability to sustain life. But not to worry, robots are helping us find the answers. This is Perseverance. It's the latest in a long line of robots destined to land on the Red Planet.
And liftoff.
Once there, it will conduct scientific experiments and investigations, building upon decades of research that began all the way back in the mid-1970s with the landing of Viking 1 and 2.
Come on.
Viking 1 and 2 both launched in 1975. They reached the Red Planet in 1976.
We have touchdown. Exit zone.
They were the first successful landings of robotic explorers on Mars.
Viking 1 and 2 transmitted photos of the Martian surface back to Earth, giving scientists their first ground-level view of the planet.
The Viking program was the first to give us these great detailed images of what looked like flood basins and what looked like river valleys, and that was really exciting to see.
In the late 1990s, exploration of Mars takes another leap forward with the landing of the first rover.
Sojourner was this shoebox-sized 22-pound rover. It had sensors it could use to analyze the soil. It also had atmospheric sensors that would tell it about the atmosphere as well.
Even though Sojourner only travels about 100 meters, its onboard instruments revealed that Mars had probably been much warmer and much wetter in its past.
Now, that information didn't tell us how it was wet. It didn't tell us it was water necessarily, but it allowed us to then think about the possibility of how Earth-like Mars really was.
We have just passed 1 minute to atmospheric entry, current altitude 121 miles, current velocity 12,084 miles per hour.
In the early 2000s, NASA begins a new era of exploration when it lands twin rovers Spirit and Opportunity.
We're seeing it on the LTP.
Spirit and Opportunity were sent to the surface of Mars on opposite sides of the planet to, in effect, do field geology.
At roughly the size of a golf cart, Spirit and Opportunity can travel much farther than Sojourner. They're also equipped with more advanced scientific tools mounted on a robotic arm.
They're able to use something called a rock abrasion tool, which is effectively like a drill, that they can put on rocks and scrape off the weathered surface that's built up over billions of years to actually get at the material underneath and take measurements.
The major thing that these two rovers were set to do was to figure out what it was that made Mars wet. Was it water as we know it, or was it some other liquid substance? Well, the data gathered by these rovers proved that, without a doubt, the features that were seen on the planet were actually made by liquid water, just like water we have on Earth. We all understand that life here on Earth is based on water. So perhaps there could have been some life, some microbial life form that developed on the planet either in the past or still on Mars today.
Spirit and Opportunity both function far longer than their planned 90-day mission. Opportunity transmits its last signal back to Earth more than 14 years after landing. When we come back, we'll look at how sending larger and more advanced robots to Mars forced engineers to develop a nail-biting new landing system.
If anything goes wrong, we're dead.
The journey to Mars is long and difficult. On average, it takes a spacecraft about 7 months to travel the nearly 500 million kilometers from Earth. And when it finally reaches its destination, one of the biggest engineering challenges of all still lies ahead. As robots become bigger, heavier, and more advanced, successfully landing them on Mars becomes exponentially harder. In 2012, NASA debuted a new landing system for use with their Curiosity rover. The time it took to land would become known as the 7 minutes of terror.
The Mars Curiosity rover, the successor to Spirit and Opportunity rovers, is more powerful, more capable.
When Spirit and Opportunity landed, they were tucked inside a system of protective airbags, which allowed them to safely bounce and roll to a gentle stop. But Curiosity is much too big for this tried and true method.
Spirit and Opportunity were each around 400 pounds or so. Curiosity rover is around a ton.
We use a lot of different things.
Instead, engineers like Alan Chin must develop an entirely new landing system. And because the enormous distance between Mars and Earth creates a substantial communications delay, it needs to function completely autonomously.
Mars is a tough place to land because the atmosphere, first off, is only about 1% as thick as that on Earth. What we do is try to test things in piecemeal, build models of those so we understand how the system behaves, and put it together in simulation.
The system they develop relies on a hard aeroshell to protect the rover as it enters the atmosphere. A series of maneuvers and a large parachute will slow it down.
Fire.
Before a harness, known as a sky crane, finally lowers it to a gentle landing.
Everything has to go right. There's no margin of error. If anything goes wrong, we're dead.
Late on the night of August 5th, 2012, Curiosity begins its descent to Mars.
We're standing by. Start guided entry.
So we hit the atmosphere going about 13,000 miles an hour, protected in our aeroshell.
We've passed through peak heating and peak acceleration. We should have parachute deploy around Mach 1.7.
There's a lot of pressure, right? Everyone's been working on this for a long time.
Parachute deploy. We are decelerating.
With the parachute out, the spacecraft jettisons its heat shield.
That gives us our first look at the ground.
We've acquired the ground with the radar. Standing by for backshell separation.
Retro rockets slow the craft down further.
We are in powered flight.
And then the trickiest maneuver begins.
Standing by for sky crane. Sky crane is started. Expecting bridle cut shortly.
All we can do is sit there, watch, and be afraid.
Signal to us, you remain strong. Rib you stable. Rib you stable.
Touchdown confirmed. We're safe on Mars.
I worked on Curiosity for 10 years. I've literally been working on it every day, trying to get these 7 minutes to go right.
Got thumbnails.
Curiosity goes on to uncover new chemical evidence in rocks, as well as seasonal variations in atmospheric methane levels that seem to support scientists' belief that life could have existed on Mars. Or perhaps even still does.
Here on Earth, methane usually has a biological origin. So this is a very interesting finding.
After the break, I get a front row seat to the launch of the InSight lander.
Liftoff of the Atlas V, launching the NASA's InSight.
And later, we look at the newest robot headed to Mars. Over the past several decades, robots have made some amazing discoveries on Mars. We now know that there was once liquid water on the surface, and that it may have even supported life. But to unlock some bigger questions about our solar system's origin and history, some missions will have to go a bit deeper. Welcome back to Exploration Outer Space. Our next robot, InSight, is designed to give scientists a very unique view of Mars, one you might even call groundbreaking. Farah, tell me, where are we right now?
So right now we're in a simulated Mars environment. I call it the indoors Mars yard. And behind us is a full-size replica of the Mars lander InSight.
InSight stands for Interior Exploration using seismic investigations, geodesy, and heat transport.
So the goal is to reveal the interior of Mars, essentially. So we know a lot about the interior of the Earth, for example. We know that the Earth is really active, that we have plate tectonics, but we don't actually know what the interior of Mars looks like. So the instruments that we have on InSight, their job is to probe the interior of Mars and understand how Mars formed, essentially.
Mars is kind of the Goldilocks of our planets. It's terrestrial, it's rocky, it's much like Earth and Mercury and Venus and even our own moon, but it's a little smaller. It's about half the size of Earth, so it hasn't gone through a lot of the plate tectonics that Earth has. It kind of holds some of the history of our evolution of our solar system.
In May of 2018, I was lucky enough to have a front row view as InSight began its journey to Mars.
Liftoff of the Atlas V, launching NASA's InSight, the first outer space robotic explorer to study the interior of Mars.
When it touched down a few months later,
Touchdown confirmed.
scientists and engineers began the delicate process of deploying the instruments that will allow us to look inside the planet.
InSight has 3 instruments, and the main one is a seismometer.
Recording seismic activity allows scientists to better hypothesize what the interior of Mars is made of.
The way that we know about the interior of Earth is because of seismology and because we've studied the way that waves reflect. So as the waves go down in the surface, they will reflect at different speeds and they will arrive at different speeds, and that can tell us an idea about the density and the stratification of the interior.
Another instrument, called the Heat Flow and Physical Properties Probe, or HP3 for short, is meant to drill down into the soil to collect temperature data.
From the thermal properties, you can also infer some information about what the ground is made of.
A third instrument measures how much Mars wobbles during its orbit around the sun. This will help scientists determine how big and dense the planet's core is.
Earth has a liquid core. That flowing metal is what causes our magnetic field, but we don't really understand what Mars looks like. We know that there isn't a liquid core the way there is on Earth, but they think that Mars might have had a magnetic field in the past because there's evidence on the surface of things being aligned in a certain direction that would be indicative of a magnetic field. So there are theories that there might have been a core that cooled down eventually.
So far, InSight has recorded hundreds of seismic events and continues to send information back to Earth. Up next, we look at the latest robot headed to Mars.
And liftoff.
Two, one,
Ever since Viking 1 and 2 first landed on Mars, robots have transmitted an amazing amount of information.
Got thumbnails.
And images back from the surface. Now, they are looking to send back more than just data. Welcome back to Exploration Outer Space. Our next robot hopes to achieve something that's never been done in the past 50 years of exploring the red planet, bringing Martian soil samples back to Earth. This is Perseverance, also known as the Mars 2020 rover. Its primary mission is to gather soil and rock core samples on Mars, and then package and prepare those samples for an eventual return trip to Earth.
The history of the planet is written in its rocks and its soil. So if you look at a core sample, you look at the layers and you step back through the core sample, it's like going back in time.
Previous missions have already shown that billions of years ago, the environmental conditions needed to support microbial life did exist. However, no actual proof of ancient life has yet been found. Bringing soil and rock samples back to Earth will give scientists a better opportunity to look for this evidence.
On Curiosity, we collected powder samples and delivered that to onboard science instruments for processing locally. But if you can return those samples back to Earth, the size and the quality of the instruments increases dramatically. So we can do a lot more.
Perseverance is designed to gather and package many different samples. To do this, it needs specialized drill bits capable of capturing everything from loose soil to hard rock core. How do you keep the core inside the bit as you bring the drill back up?
So taking a look at this plastic bit mock-up, you'll notice how the tube is thicker on one side of the bit than on the other side. As it drills into the rock, the eccentricity is lined up so that the sample goes right into the bit and into the tube. Once we get down to the bottom of the core, we need to break it off. The way that we do that is we rotate the bit relative to the tube.
The hole gets smaller.
And the hole gets smaller and it creates a shear that snaps off the end of the core.
Another bit is designed to capture loose soil.
You can see it has holes on it. You can see the opening right there. And it will rotate as we insert it into the soil.
This rotation traps the soil inside the collection tube. Each tube holds a 10 to 15 gram sample.
We then take that tube and we process that and we seal it. Then we find a nice location on Mars and drop them off for future return to Earth.
When we come back, Perseverance heads to Mars.
3,
2,
1.
And liftoff.
This is the scene at Cape Canaveral Air Force Station, Florida, as technicians begin the final preparations to send Perseverance to Mars.
Perseverance is powered and ready to go.
It's 4 in the morning. We're awake. Let's watch a robot launch to Mars.
Launch sequencer start.
Since I can't be there to watch in person, I'm at home, glued to the coverage.
1 minute.
Just like many of our friends from past seasons.
0 is set.
1 minute.
There you see on your screen a beautiful shot. The skies look great.
30 seconds. Let's go find life on Mars.
Go, Centaur.
Go Mars 2020. There we go. We are ready to go liftoff. 7, 6, 5, 4,
3,
2, 1. And liftoff as the countdown to Mars continues. The perseverance of humanity launching the next generation of robotic explorers to the red planet.
Vehicle is now passing through max Q, maximum dynamic pressure.
Oh, that's so cool.
Standing by for stage separation. and we have Atlas Centaur separation.
Humans just launched a robot to another planet.
In February of 2021, Perseverance reaches Mars. It lands at Jezero Crater, a spot chosen because scientists believe it was once an ancient river delta, and therefore could have evidence of the ancient life Perseverance aims to find. Now on the surface, Perseverance will begin packaging the samples that another robotic mission will hopefully bring back to Earth by the year 2031. It will also conduct additional experiments, like launching a small helicopter called Ingenuity, to see if powered flight is possible in the super thin Martian atmosphere. And testing the Mars Oxygen In Situ Resource Utilization Experiment, otherwise known as MOXIE, to test out a potential method for creating breathable oxygen. Both are designed to help pave the way for eventually sending humans to Mars. But until that day comes, Perseverance, along with Curiosity and Insight, both of which are still operating on the surface, will continue to lead the way in exploring the Red Planet, just like all other robotic missions that came before them. I'm Emily Calandrelli, and we'll see you next time on Exploration Outer Space.